Hello everyone. We'll start with the surface chemistry, chapter 5. So, first of all, what is the meaning of surface chemistry? So, it is branch of chemistry which study the phenomena occurring at the surface. So, what is the surface here? The surface which separates the two phases, two bulk phases, right? Uh, like we add oil and water, we'll see the oil floats on the water, and we can see uh, this boundary which separates the two liquids. So, what is happening on the boundary of oil and water is studied under the surface chemistry. So, dissolution, addition of a sugar in water, salt in water, any solid in water in a liquid, dissolution processes, gas when on the surface of a liquid. So all dissolution processes involves the study of the changes at the surfaces also. Crystallization means the appearance of solid back from a saturated solution. Corrosion, electrode processes, all is under surface chemistry. Now, the first topic in this chapter is adsorption. So, adsorption is the accumulation of a species at the surface rather than in the bulk of a solid. So, when we add sugar in the water, it goes inside the water. So, here, in case of adsorption, we'll talk about the accumulation of species at the surface only, like a dirt deposit on a surface of a table, on a glass kept on a table becomes contain dust particles after some time, and those dust particles are only at the surface of the glass, not inside the glass. So accumulation of the molecular species at the surface rather than in the bulk. Bulk means inside the substance. So this phenomena we cannot talk about gases for gases. It may be for gases on solids, gases on liquids, solids, liquids on solids, but it cannot be for gases in gases or gases on gases. So molecular species on the surfaces of solids and liquids. Right. Now, it is a surface phenomenon, and the substance which is being adsorbed on the another substance is known as adsorbate. Which is being adsorbed. So dirt, in case of dirt and glass, dirt is adsorbate. And the other substance on which adsorption taking place is known as adsorbent. So here are the definitions of adsorbent and adsorbate. Now next is a desorption. Desorption is the reverse process of adsorption. So heating the surface, shaking the surface will promote this process. So process of removal of adsorbed substance from a surface is known as desorption. The next topic is absorption, the normal process which we came across in our daily life, which we already studied in the lower classes. So here the substance is uniformly distributed. It cannot accumulate at the surface, but it uniformly distributed throughout the solid. So it means at the surface also, inside bulk also. It is the bulk phenomenon. Concentration is uniform, but in case of adsorption, the concentration is more at the surface than in the bulk. Here, the concentration is uniform throughout the bulk of the solid. Another term is sorption. Simultaneously, the processes absorption and absorption when takes place is known as sorption. Right? So then next term is enthalpy or heat of adsorption. Now, as adsorption is a uh, spontaneous process, so it releases energy. So it is exothermic in nature. So whenever adsorbate comes to the surface of adsorbent, it releases energy, and that released energy is known as enthalpy or heat of adsorption. So this is for 1 mole, because the heat of adsorption or the enthalpy of adsorption values are always given per mole. So when 1 mole of adsorbate adsorbed on the surface of adsorbent, so the heat release is known as heat of adsorption. Next is adsorption types. So there are main two types, physical adsorption and the second is chemical adsorption. So physical adsorption means no chemical interactions in between the adsorbate and adsorbent. No chemical bond is formed. But in case of chemical adsorption, the chemical bonds are formed between the adsorbate and adsorbent. So next is the difference between the physiosorption, which is physical adsorption, and chemisorption, which is chemical adsorption. The first is here the adsorbate is held at the surface of adsorbent with weak forces, with only physical forces, no chemical bond in this form. However, in case of chemical adsorption, there are strong interaction in between the adsorbate and adsorbent molecules, and chemical bonds are formed. As no chemical bond has to be formed in case of physical adsorption, so there is no specificity. Any adsorbate can be adsorbed at any adsorbent. So in case of chemical adsorption, this is highly specific. Only those can be undergo this process which can form chemical bonds. Physical adsorption is reversible. So as no chemical bond is formed, so it can be reversed easily. This chemical adsorption is irreversible. Now, in case of physical adsorption, it depends on the nature of gas. It depends on the nature of gas. Like easily liquefiable gases can adsorb more greater than the other. So here in case of chemical adsorption, there is no such thing. It depends on the nature of both gas and the solid on which it is going to be attached. If they can react, they can form bond, only then this process can be happen. So there is no dependence on the critical temperature of the gas. Critical temperature, the temperature at which the gas can be liquefied. Now the extent of adsorption increases with increase in the surface area of adsorbent. So when we uh, activate means crush the surface that is solid, which increases its surface area, means it exposes more area to the adsorbate molecules. So adsorbate molecules find more area to attach on the adsorbent on activation or on making the fine particles of the adsorbent. So this point is same in both the types of adsorption. So both adsorptions increases with the increase in the surface area of the adsorbent. Uh, so weak forces of attraction. So here are the strong forces of attraction, the same point. In case of physical adsorption, the enthalpy of adsorption is very low as there is no chemical bond is formed, and this value of enthalpy of adsorption varies from 20 kilojoule per mole to 40 kilojoule per mole maximum. And in case of chemical adsorption, the enthalpy of adsorption varies from 180 minimum to 240 kilojoules per mole. So it is quite high as compared to the physical adsorption. Low temperature is favorable in case of physical adsorption. However, slightly more temperature is favorable in case of chemical adsorption, but not too much high. No activation energy is required. Now, the activation energy is the amount of energy which must be required for uh, uh, required by a reactant to get converted to the product. So here the reactants are adsorbent and adsorbate. So the minimum amount of energy which must be associated with these two, which can form chemical bonds. So that should be required in case of chemical adsorption only. However, in case of physical adsorption, no such energy is required. So before going to the products, the reactant molecules first of all achieve an energy value which is known as threshold energy. And to go to that threshold energy value, they have to gain some uh, amount of energy, and that amount of energy is known as activation energy. And this activation energy is required only if the species are undergoing chemical change. So only in the case of chemical adsorption it is required, and it is not applicable in case of this physical adsorption. Now, physical adsorption is non-specific, so it can form multi-layers of adsorbate molecules on the adsorbent. So this is the adsorbate molecule. So first layer of particles come and they came and they attached, and then after it, the second layer can be attached over there. So multi-layer adsorption can be happened in case of physical adsorption, but whereas in case of chemical adsorption, only unimolecular layers can be formed. After that, physical adsorption may be there, but no chemical adsorption over it. Physical adsorption may occur over this, but chemical adsorption gives only single layer, that is unimolecular, because it is specific in nature. The bonds will formed only in between the adsorbate and adsorbent molecules. After that, physical adsorption may happen, but no chemical adsorption. Chemical adsorption gives unimolecular layer only. But in case of physical adsorption, multi-molecular layers can be formed as there is no specific criteria for this. Now, here is the graph which gives the effect of temperature on physisorption. So it always decreases with the increase in temperature. Now this is the amount of adsorbate on a per unit mass of adsorbent. So in case of chemical adsorption, the graph first increases to a value, then decreases on further increase in temperature. So this increase is due to the achievement of activation energy. But if too much temperature is there, then the adsorbate particles get high energy. They will not retain on the surface of adsorbent, as the high temperature always lead to the desorption. So up to some level, temperature favors the chemical adsorption, but too much temperature again decreases the chemical adsorption. So this is all for today. The next part will discuss the factors affecting the rate of adsorption. So bye for now. Thank you.